Okay. Attention over here. Algebra 1B on Trooper Tide Tuesday on the School Race Trooper Tide Tuesday Christmas edition. Okay. Okay, what does SWBA stand for?
Student will be able to tease highlight.
Very good, okay? Solve systems of equations by graphing. Section 4.8, okay? Phones are away. Okay, phones are away. If we need to, we'll take the music out, guys.
No, let's eat on these nuts.
Okay. Hey, if we need to, we'll take the music out, okay? Okay. Yeah, I feel that, dude. I already done Mr. Cross nice to meet you. So we have a system of equations, okay? What is a system of equations? A system means there's some organization to something, okay? Now, this is going to be a set of a set of two or more linear equations. So sometimes you can get up to 3, 4, 5, so many systems of equations. We won't deal with any more than 2 in this class, okay? But it's a set of 2 or more linear equations containing 2 or more variables. Oftentimes, stop. Hey, Katie. You need to stop something on. It's distracting me. Okay. Katie. I'm not saying I can still hear you. Thank you. Okay. So in this class, once again, we won't deal with any more than 2 variables. Because whenever you deal with 3 equations, you have 3 variables. 4 equations, 4 variables, so on and so forth. So when you have 2 equations, you normally have 2 variables with them, our x and our y. Now they're used to represent situations and solve problems normally related to consumer economics, finance, and geometry. So a lot of times it deals with like the cost of some things, okay, that kind of stuff. So it's actually pretty useful. Okay, I feel like this one's one of the more useful things we can do in this class. Not that nothing useful, but I feel like this is one of the more practical ones that apply to us. Okay. Now we have some different ways we're going to learn to solve. Okay, this is the one we're going to learn today. It's called solving by graphing. Okay, we've been dealing with a lot of graphing this chapter, right? We've been graphing lines like all the time. Okay, we've just been learning totally different ways to graph lines, whatnot. Okay, so we're going to solve by graphing because we know how to graph. So if 2 lines are graphed, they always meet at one point. If 2 lines are graphed, they'll always meet at one point unless they're parallel or unless they're the same line. We'll talk about those scenarios. So unless they're parallel, which means they never touch, or they're the same line, they'll always meet at one point. Now the point where 2 lines meet is called the intersection. And we write the intersection as an ordered pair. How do we write ordered pairs? What comma what? X comma y. Very good, Brady. Okay. We write ordered pairs as x comma y. I know that parenthesis kind of got off on the edge, so that's kind of weird. I need to fix that formatting. Or I myself will know. Okay. So we write it as an ordered pair. So these 2 lines will meet at an ordered pair x comma y. Now before, what we found was there's lots of different solutions to these graphs. When we just had one line, we had lots of different solutions. All of those solutions made our points. Remember when we made those tables? We plugged in x, got out y, plugged in x, got out y, plugged in x, got out y. And they made all of these solutions, and they were all different points. Well, now what's going to happen is when you have 2 equations together, there's only going to be one solution. There's only going to be one time when it works for both of them. There's only going to be one x and y combo that works for both of them, okay? So we're going to have some steps for solving these, okay? So let's look over these steps. It's not going to be as intimidating as we think it might be, okay? Step 1, put both equations into slope-intercept form if necessary. Someone remind me, what's slope-intercept form? Y equals mx plus b. Can somebody tell me why we like y equals mx plus b?
Because some random smart guy made it up and it sounded good.
Okay, some random smart guy made it up sounding good, okay? Why else might we like it? It's easy. Why is it easy? I agree with you. Why? Okay.
But they just plug the numbers in.
Plug some numbers in. Okay. Do we know what our m is instantly in this?
Basically.
Yeah, it's whatever's with x. And do we know what our b is?
Yeah.
Yeah, and that's our starting point.
Yeah.
So whenever you have it in this form, it's really easy to graph because we go bada bing, bada boom. Starting point slope. Okay. It is. Okay. You should stand in the corner. Okay, because it's 90 degrees. Okay. So.
Oh, I just got that.
So we put both equations. We have 2 equations. We put them both in the slope-intercept form if necessary. So just like when we graphed, Okay, just like when we graphed one line, and we were just given the equations to graph the line, we put it in the slope-intercept form if we needed to. So sometimes you don't need to do this step. Second, you graph the first equation, and we like to use a ruler to draw this line or a straight edge of some sort. So that's a second pencil, a notebook, a phone, something like that, okay? So we graph the first equation, then we graph the second equation, then you write down wherever they meet. Okay? So, slope-intercept form, which we've done before. Graph a line, we've done that before. Graph the second line, cool. Okay? Write the point. Let's practice this here. Number one, how many equations are there? Two. Now this little fancy thing over here, that brace, okay? All that's saying is saying, hey, these two equations go together. We're saying these two equations go together, okay? So it's a system. That's how we just show or notate or write out, hey, this is the system. So we have two equations. Now, step one, put both in the slope-intercept form if necessary. Is the first one in slope-intercept form?
Yeah.
Yeah. Is the second one in slope-intercept form?
Yes.
Is y by itself? Yeah, so step one's already done. Cool, we already got one step done. Step two, graph the first equation. Y equals negative 2x minus 1. What two things we need to identify out of there? The negative 2, which is what? That's our slope, our m. Very good. And what else we need to identify? Negative 1, what's that? B. Now, which of these two is the point we begin with? The negative 2 slope. The 1. We begin with B. You guys hear that? Begin with B. We begin with B. So negative 1, where's that negative 1 at?
Right there.
Right where? Here?
There. Yep.
Right here?
Mm-hmm.
I disagree.
Yeah.
Where are we looking for?
Where would I put this negative 1 at? I go down. It's negative 1 on the y-axis. It's the y-intercept, okay? That's our y-intercept. That's why we call it slope-intercept form, because we know our slope and our y-intercept, our m and our b. Okay? So now we have our slope of negative 2, or a negative 2 over what number secretly? 1, okay? So what direction do we go to? Try again. Try again.
Down.
Down. It's rise over run. We go down 2. In what direction do we go 1? To the right. So let's graph those 2 points if you haven't already. Okay. And then, if I were to go back to my original point of the negative 1, B, what direction also could I go? Up 2 to the left 1. Can I connect those points?
Yeah.
Yeah, and I want you guys to use a straight edge or a ruler of some sort. You practiced that before, right?
It is why.
Okay.
Because
We'll see why on this. Hey, we'll see why on this one, trust me. Okay? I'm just gonna keep making more points instead though, because I don't have a good straight edge for up here. And I can just keep counting the slope and keep making more points. And just start.
Oh,
I'll give you an example, Brady. Yeah.
Wait, how'd you get it?
I just made more points by counting because I don't have a good straight edge up here.
Oh,
Okay.
okay.
Sure you
So
did.
all we need is just 3 points right for ours.
Yes. Yep. But then I want you to use a straight edge.
There's
And I'll
not
make
a
sure.
right tool.
Maybe it's.
Yeah, go click on your toolbox.
I'll use it later. I'll play with that later. That's a good idea though. Okay. So next, we graph the first line. Now we're gonna graph the second line. So we need our m and our b for the second line. Y equals x plus 5. What's the m here? Hayden? 1. Very good. What's our b going to be here? Okay. Tony? Nope. X plus 5. What's our b? 5. Very good. Okay. So what point do we start with? Which one of these do we start with, the m or the b? We begin with b. So where do we go 5? From the origin, where do we go 5? Up 5. Very good. So now where do we go with our slope? Of 1 or 1 over 1?
Right one, down one, or
Okay.
right one, up one,
Up 1, right 1. Where else could we go? Down 1,
Right, or left.
left 1. Now, which way do we think they're going to intersect? Is it going to intersect up here? No, where are they going to intersect?
Right.
Down here. So what direction do I need to keep going? This
Down.
way. Okay, and I'm going to connect those points. And do we notice that there's one spot where they intersect?
Yep.
So now, so we graph the third, we did the third step, we graph the second line. So now, where do the two lines meet? Grayson, I heard you saying it.
-2, 3.
-2, comma 3. Okay, so they intersect at -2, comma 3. So, that's step 4. Step 4 is literally just writing it down where they meet, writing your answer down. -2, comma 3. That's where they intersect. Okay? Hey, you guys remember how before we plugged things in to see if they work for these equations?
Uh-huh.
Okay, we can check this the same way. Let's look at this here. Okay, we can check this the same way. See how it says check? Okay, what that means is I'm going to take each equation. I'm going to start off with the first one. Y equals -2x minus 1. And I'm going to plug in -2, comma 3. So where's the -2 going to go? The x to the y. The x. So where's the 3 going to go? Y. So we have 3 equals -2
About to
times
put my note up.
-2 minus 1. Ready, please follow with me. Then we'll have 3 equals, okay, what is -2 times -2?
That's positive.
Positive 4. And does 3 equal 4 minus 1?
Yes.
Does 3 equal 4 minus 1? What is 4 minus 1?
3.
3. So does 3 equal that?
Yeah.
So 3 equals 3, it checked out. And we can also check the other equation to make sure it works in both. Y equals x plus 5. So we plug in -2, comma 3 into both of those again. 3 equals? Equals? -2 plus 5. Hey, what is -2 plus 5? Positive 3. So does 3 equal 3? So it works in both of them. So notice, we can check to see if we got these right. We can check to see if we got them right by plugging whatever our solution is wherever they both intersect and getting it. Now the reason why we need to use a straight edge, guys, you guys ask, why do we need a straight edge now? Okay? Is because what if you get a little bit off? Is it going to change your answer?
Yes.
Yeah, because we're trying your answer by the way it looks. So you have to make sure you have it right, okay? So whether you're counting out more points for slope like I did, okay, or you're using your ruler. Recap. Okay, recap. 1. Put both equations in the slope-intercept form if necessary. We didn't have to do that one here. 2. Graph the first equation. 3. Graph the second equation. 4th, find where they intersect, write the point. Do we think is this really any new math?
Nope.
No, all we're doing is instead of having two lines on 2 different graphs, we're putting them on one graph and just saying, oh, where do they touch? Okay. On the second one here, okay? Hey guys, on the second one here, what do we notice about these 2 lines? We have to change it into slope-intercept form. What do we have to solve for? We have to solve for y in both of those, okay? So I want you guys to go ahead and try solving for y in the first equation. Yes. Okay. Actually, let's go ahead and we'll solve for y together in the first equation, but I'll have you guys solve for y alone in your second one, okay? So the first equation here, we don't have a ton of room. Okay. He's talking to us, really distracted.
Sorry, I just really need the answer.
I know. Okay, for sure. Okay. So if I write down -x plus 3y is equal to -9 here, we have to do our step 1. We have to try and get y by itself. Okay. Notice I'm writing it small to give myself room. Okay. Okay. Looks like you were spacing off there. Okay, that's what I thought. Okay. So in order to solve for y, we have to add x. Okay. Caden, and then let's
I didn't even
okay.
sing, did
Sorry, Caden,
I didn't say nothing.
Caden, you just sung.
No, I didn't sing the song. I said I wish Juice wasn't dead. Because he died.
Okay. So we add x to both sides. 3y is equal to x minus 9. Right? What else would we do?
You have to divide by 3.
I know, I'm gonna do it after, and
You're
I'm
wild.
watching to pay attention.
Divide by 3 on both sides.
What the? You have a little.
Always split it up. X over 3 minus 9 over 3. So we get y is equal to x over 3 minus 3. So that's what we end up getting when we solve the first equation for y. Y is equal to x over 3 minus 3. So now that y is by itself, what can we do?
You can
Plot
plot.
Yeah, we can identify the m and the b though, right?
Yeah.
Okay. What's our m and our b?
3, -3, and whatever that would be.
Okay, so the m is something else, and the b is -3. X over 3, what's secretly with the x?
3. Oh, 1.
1.
So what's our slope?
1.
1 over,
3.
because 1/3 is with the x.
And you plot by b,
Okay.
so negative.
Well, let's hold on a second. And let's, actually, no, we can graph it, never mind. Yeah, let's go and graph this one. Okay, so we plot by b, go ahead, Gracie, keep going.
How you plot -3 on the y-axis.
That's real.
Right, guys?
That's real.
Right? And then what?
And then you go up 3
Up
over
1.
well, up 1 over 3.
We're gonna go down 1 and where?
Okay, we'll give it a money, this is a pain. I was just copying what the guy said to you. I was ready to. I was ready to throw a haymaker shot back to you.
Who?
Why don't you try the line thing right now? It's right there, right below the button.
Actually.
Try the direction real quick.
Yes.
Now you go after.
Now, we graphed the first line, right? What's the next step?
Then you gotta change the second one in the y-axis.
Yep, now we gotta graph the second line, which means we gotta change,
See?
now we gotta change the second one in the slope intercept form as well to solve for y, okay? Good. Okay, so I want you guys to solve the second equation, okay? So this 2y, 2x plus y is equal to 4. Go ahead and solve that one for y, identify m and b, and go ahead and graph that one.
Wait, are we allowed to switch the 2x to 4?
What do you mean switch?
Cause like,
Put the 2x first.
yeah, when I brought it like by itself, it was y equals 4 minus 2x.
Yep, you can do negative 2x plus 4.
Okay.
You just gotta keep your negative with 2x.
We started 2.
Pretty good.
Wait, so if we start at 4, do we go up 2 and then right 4?
What's our slope?
Our slope is.
Your b is 4.
Oh, my slope is 2. -2. But I thought we started.
You start with b, and then you use your slope from there.
So. So right. 4 is the 2. What did I do wrong? So you go down.
Doesn't negative 2 over what?
Over 1.
B. With b.
Yes, so go. Oh, up 2.
Well, up 4 from the center.
Get there.
Or
Up 2 and then run 1.
that's negative. So if you go down 2, what direction? Right one. Yeah. You went down 2 left one.
Oh, so I have to go
Is that right?
up 2, left 1.
So for this, we just go 4 up. 1, 2, 3, 4.
There.
It goes on the y-axis because it's a y-intercept. Then, how we find our additional points is we use the slope of -2. So -2. Yep.
This.
So you gotta find where they intersect.
It is 3.
Don't blurt, don't blurt.
They intersect at.
Don't blurt. Okay. So for this one to solve the equation for y, we need to subtract 2x. Y is equal to negative 2x plus 4. So what's the m here and what's our b? In order to graph these, we need to find our m and our b. So here, what's our m? Negative 2, very good. What's our b? 4. What do I do with this now? Wait till we finish this one. Okay. What do we do now? What do we start with?
You start with 2. No, 4.
4. Begin with b.
Begin with B.
So where do I go from the center?
You have to go up 4.
Up 4. Do I go left or right at all?
Nope, straight up.
Just like in basketball, if you're blocking a shot, go straight up.
No, you squat right at their face.
Oh, yes. I tried it. Okay. So now, slope is secretly negative 2 over what number, Brady? Yep. So Brady, you got this right. What direction do I go to? Down. What direction do I go? 1. Very good. Now, could I also go up 2 left, right, 1? Yeah. Now, what direction am I going to be crossing these, though? Am I going to be going down to the right? Are they going to intersect over here or up here?
Down there.
Down there. Okay. So I keep going here. I keep connecting the line.
3, comma, negative 2.
And it does intersect exactly at 3 comma negative 2. Okay? It does intersect exactly at 3 negative 2. Okay? So notice, is this really that much more work than just doing one equation? No, not really. We're graphing a second one and then saying, oh, where do they go? Okay? So compared to what we've done, the math hasn't really gotten any more complex.
Since kindergarten?
No. From like where we were a few sections ago.
Kindergarten did 1 plus 1. I missed out stuff. 2.
Yes.
Okay.
Yeah. So we can go ahead and check this one as well. So we can go ahead and check this one as well by plugging in the original equation.
You can say that.
Okay. Hey guys, as you check it, we would plug it back into the original equations like negative x plus 3y is equal to negative 9. And you plug in 3 for x and negative 2 for y. So negative of 3 plus 3 times negative 2. Let me say equals negative 9. Well, negative 3 and 3 times negative 2 is negative 6. Does negative 3 plus negative 6 equal negative 9?
Yeah.
That's why I check that's true. Checks, works out.
Last you checked.
So then we put next one, 2x plus y equals 4. I plug these in to see if they work. 2 times 3 plus negative 2 equals 4. So hey, 2 times 3 is 6. Negative 2, 6 minus 2. Does 6 minus 2 equal 4?
Yeah.
Okay, you said you missed 1 plus 1? Same thing, right? 6 minus 2 does equal 4. Okay, check. Now what would happen if it didn't work for one of those?
Then that's
wrong.
Then we did something wrong, okay? But this is the way we can check our work to make sure we did it right. If it works for both, boom, we did it right. Okay? Question on this, guys?
No.
Okay. So are these steps really anything new that we're doing?
No.
No, really all the only new thing is saying, oh, where do they touch?
You have to check.
No.
Okay.
But you can know if you got it right. We're gonna see if we can identify solutions. We've already done this. So it should come naturally, more naturally. What we're gonna do, guys, is we're gonna be given an order pair. Like here, in example 1, we're given 4, 1. We're given a system. And we're asked to tell whether this ordered pair is a solution to the system. So what do you think we're gonna do with 4, 1? What do you think we're gonna do with this and these two equations? Any guesses? To see if it's a solution? plug them in and see if they work. If it works in both, then yes, it's a solution. If it doesn't, then it doesn't. And that's what it says. Plug the point in for x and y in the first. Plug the point in for x and y in the second. Determine if it's a solution. If both are true. So we take this and we plug it in. And somebody help me plug it into the first equation. Somebody help me plug it in to x plus 2y is equal to 6.
So 4.
Okay.
Plus.
Yep.
2.
Yep.
Times.
Yep.
Or times 1.
Yep. Equals 6. Very good, Brady. Okay. Now we go through and we do that math. Okay. So Tony, what do we do first? 4 or the 2 plus 1? 2 times 1 is 2.
2 times 1.
Okay. And 2 times 1 is?
Yeah.
2. Does 4 plus 2 equal 6?
Yep.
Yep. Checks out. So now what do we have to do? The next one. Our x minus y equals 3. See if this one works. Sierra, can you help me plug this one in?
This is yours.
I have another one. 4 subtracting equals.
Here we go. 4. Yep, 4 subtracting the 1. The y is equal to that, yeah. When we say equals 3, well hey, does 4 minus 1 equal 3? Yeah. So 3 equals 3, it checks out. So is this ordered pair a solution to the system?
Well, I lost my pen.
Yes, it is. Yeah, let's watch our math. Now you're upset.
After the payment.
You lost the pencil?
It's right here.
Yeah. Okay, let's go ahead and try the second one on your own. Okay, we're seeing, does this order pair work?
So it came immediately from the Little Caesars.
I have no idea.
There's literally one cool person that works there.
Who?
It's Marty.
I might have personal. Motivated book.
I agree.
I wish that. They're pretty dope. It's actually kind of, he's funny. Yeah, the person that works there.
Okay, I agree with the first one.
We're making crazy bread. He starts crazy. He starts screaming. It's like you're
Tony,
what? Cuss.
okay, you're very close and you're censoring off the last syllable, so we're not gonna do that.
What?
Let's go get 2 times 1. So positive 2 plus positive.
Ooh.
The second one is not right.
So is it a solution? So is it a solution for the system? Are both equations true?
But this week feels so slow already.
Alright, is restrictions true?
Yep, I agree with the first one.
These are confusing. That's a thing.
Do you have the 2 y to the x?
Well, right now we're not solving, we're plugging in the ordered pair, seeing if it works.
Yeah, you still have to solve it, don't you?
Just plug these in to there, and then simplify one side. Okay. So, this first equation, x minus 2y is equal to 4. I'm not solving for y. You're just plugging these in. So notice here how we plugged 4 and 1 in. We plugged 4 in for x, 1 in for y. We plugged 4 in for x.
So this one, we will put 2 in for 2 in for x.
Yeah.
So that it would be 2x.
No, just 2. Because the x goes away, because 2 is x.
Okay. And then for negative 1.
Hey, how about this? When you substitute things, when your coach substitutes you in, are both running backs on the field anymore?
No.
No, it's just you. So when we substitute 2 in, do we still have x on the field?
Yeah. No.
No, you don't have 2 running backs on the field. You're not gonna have 12 men on the field. Okay? You're not gonna have 2 and x there. You just put the 2 in, 4 in.
Okay, so then we would go minus, and then we'd go 2 times 1.
2 times
negative 2 minus 2 is 0.
What about ratio? What comes first?
Parentheses.
So what's the multiplication? It's negative 2 times negative 1.
It would be 2. Yeah, 2. And then, and then we would go, after that, we would do this, so 2 minus 2.
Careful. So you said it was negative 2 times negative 1. So it's actually a positive number.
Expenses.
Because it would be 2 plus 2.
Yeah.
Plus 2 is that equal to what?
So that works. Let's try the second one then.
Okay.
I agree.
I think I do that.
Okay, so this one we
I
just
agree.
added on, right?
Both rows?
So this one we added on, so it'd be
So it's
2 plus 3 is
What's happening in 3 next?
3 next is being multiplied.
Okay. So hey, on a play. Okay. Let's say quarterback's gonna hand it off to the running back. Okay. Doesn't matter who the running back is or what they're gonna do. No, they're gonna hand it off each time, right? Okay. So if 3 is multiplying with x, what's gonna happen if we plug 2 in for x? But if 3 is multiplying with x, what's gonna happen if we plug 2 in for x? Are we still gonna multiply?
No.
Okay. Will the quarterback hand the ball off the same way they would to either running back?
Yeah.
Yeah. So we're gonna multiply no matter what is there for x.
Yeah.
Yeah. So if 3 is multiplying with x,
Yeah.
we're not gonna change the play call just because we put 2 in. We're still gonna hand the ball. We're still gonna multiply it. So we're still doing 3 times 2 because x
So
will
then
then 3.
it would be 6 plus negative 1 equals 6.
And okay, what I want you to do to see this is rewrite this. Please write down your chart too.
It's not even in his ear.
So 3 times 2. Let's turn that down because I can hear it. I don't hear the good words.
That's not that word.
I heard it that word.
What was it?
The culturally inappropriate word.
Okay, so that'd be
So see how
6 plus
see how when I write it like this, I just took the x and I replaced it with 2. You know this is multiplication, don't you?
what?
Do you know that this is multiplication?
Yes.
Yeah. But before you were guessing. So see how when I write out this way, I take that extra step. See how you knew what to do.
So then it would be 5, so it's not true.
Yep.
So let's talk this one up here, guys. So
Well,
the first
it's not
equation,
true.
x minus 2y is equal to 4. Plug in 2 for x, plug in negative 1 for y. Okay. Let me say it equals 4. Okay. 2, negative 2 times negative 1 is positive 2. 2 times 2 is 4. Checks out. Second equation, 3x plus y is equal to 6. Stop. Okay. 3 times 2 plus negative 1 equals 6. Well, 3 times 2 is 6. 6 plus a negative 1, is that going to be 6? No, it's 5. Does 5 equal 6? No. So we ask, did this ordered pair work in both equations?
No, sir.
So no, it's not a solution. It's only a solution if it works in both equations, okay? It's only a solution if it works in how many? Both. Thank you, Brady. Okay. Got a little bit more here, guys. Okay, let's look right below this. Okay? Actually, for me, it's right below it. On you guys, for you guys, it's the next page. I changed it up on your guys because I realized after I worked through you guys, it might be a good time more room. Okay. So, if 2 lines are parallel, earlier we said there are cases where we have parallel lines, and that's the case when we don't have one specific solution. Thank you for putting that on. I appreciate it. Parallel lines are gonna have
Because Jesus Christ.
Thanks.
That's really not, you will not like that. You're too
Why this
Appreciate
is
that.
a whole song.
Okay, no. I don't appreciate that Amy using you in that way. Really don't.
I can't even not say it like that. That's not like I'm saying it in vain.
Yup, others being done.
Alright.
If 2 lines are parallel, how many times do they get across?
Never.
Never. So 2 lines are parallel,
0 times.
they're going to cross 0 times. So we're saying the solutions are where they cross. So how many solutions will it have?
0.
0. If they never cross, they'll never have any solutions. So if 2 lines are parallel, they'll have 0 solutions because they will never, ever, ever cross. Okay? He says the solution is wherever they cross, intersect. Parallel lines never do that. So they don't have any solutions. Now, if 2 lines are this fancy word, guys, we use this fancy word, we call it coinciding. What that fancy word means, guys, is it really just means that they are the same line. So if you just write underneath that coinciding, that they're the same line, that's really what that means. So if two lines are the same line, they have infinitely many solutions because they share every single point on the line. Can you guys, I don't know if you have any difficulty. Yeah, can you guys turn it down? I can hear it. Thank you, I appreciate it. Okay. So if two lines are the same line, they're going to have infinitely many solutions because every single point they have is shared. Okay? So let's continue on right below. So we have two more examples and we're done with this note packet entirely. Then we're done with notes for this calendar year. Okay? Then we're done with notes for the semester, which will take us through December. It is taking up money, right? Or you just peek on the next page. Oh, there's nothing, okay? So, over here on our very last example, okay? We're gonna graph these the same way. So what's our first step? To do what? Yes.
We have to get the y by itself.
We have to get the y by itself for both equations. Does the first equation have y by itself yet? No. Does the second equation?
Yes.
Yeah, okay, so we just need to get the first equation's y by itself. So we have the equation 3x plus 2y equals 6. Okay? So, how do we get y by itself here?
Sorry.
Subtract what? Yes, thank you. Gracie was dying there, so thank you for tapping in. Okay. So we have 2y is equal to negative 3x plus 6. Gracie, I appreciate your commitment to math, the silly answer, even while you're in the midst of dying. Okay. That does not go unnoticed. Okay. So how else? What else do we do now?
Divide by
Juice
two.
Divide by 2. Very good. Grady's got it. Y is equal to negative 3 over 2x plus 6 over 2. Hey, does 6 over 2 simplify? Does 6 over 2 simplify? Yeah. So y equals negative 3 over 2x plus 3. So now that y is by itself, how do we graph this line? What do we need to identify, Caden?
Rise over run.
And we need to identify our slope, which is our rise over run. And what else do we need to identify?
We need to identify the b.
B. What's our slope here?
3 over 2.
Negative 3 over 2. Good catch. What's our b here? 3. Now, which of those do we start with? 3. We begin with b.
Begin with
B. So we go up 3. And from there, where do we go?
Left 3.
Down 3.
Oh,
And where?
right 2.
Right 2. Very good.
And then up
The negatives also should look downhill. Okay, yep. Or from the starting point up 3. Keep going, Anthony.
and then left 2.
Left 2. Very good. You've nailed those. Okay.
What's the average SAT score?
No idea.
We have the highest dropout rate.
Classmate?
We should be proud of
Okay, can I try the next one out?
This next one is already solved for us.
Yeah.
Okay.
So
So what's our m and our b? Go ahead, Keith.
Our m is negative 3 over 2,
Okay.
and then
The m is negative 3 over 2.
our b is 1.
Negative
Negative 1.
Negative 1. So our m is negative 3 over 2, and our b is negative 1. That was already solved. That's nice. We like when they're already solved. That's less work. Okay? So what do we start with here?
Negative 1.
Negative 1, our b. And where do we go from there?
Down 3, right 2.
Down 3, right 2. Or where else could we go?
Up 3.
Very good.
Ooh, they don't touch. You don't ever touch.
Why don't they ever touch?
Because they're
Parallel.
They're parallel. Hey, what do we notice about their slopes?
They're the same.
They're the same.
And what do parallel lines? They have the same. So could we have known that they might not touch already?
Yeah.
Yeah, because their y-intercepts are different, so they start at different spots, and they have the same slope. So what's the solution?
Mr. Cross, you have some strong pencils, dude.
Are there any solutions?
No.
No solution. There's no solution, because they're parallel. Okay? The reason there's no solution is because they're parallel. Okay? Does that make sense?
Yes, sir.
Okay?
I can do this next one for us. Start at negative 2.
Okay. So this next one, our m is, go ahead, Tony.
Negative 2.
Our b
Oh,
is,
1/4.
yeah, our m is 1/4. Goes with the x. Y is already by itself. What's our b?
Negative 2.
And now you said we begin with b, so negative 2. So I I go down 2.
Yep.
And help me out from here.
And then go up 1.
Yep.
Right 4.
Perfect.
And then go down 1.
Yep.
Left 4.
Also perfect. Okay, good stuff. Okay? Cabinet.
Is that a negative one? The M?
And one note is positive 1 over 4, but it's not negative there.
Yeah, so what is it?
We went down 1, but you also go left 4.
Oh,
So we
okay.
originally went up 1, right 4, because positive, positive. But we said we can flip it, go the other direction. Does that answer your question?
Yes.
Okay, go.
Thanks, open lady,
Yes,
boys.
you already know. Okay. Second one. 1/2 x minus 2y equals 4. Wait a second. Is that y by itself yet?
Nope.
Can we get it there?
Yeah.
How?
That too.
Okay, what do you want to think first? Before we deal with the 2. Okay, what do we
Minus
wanna do?
1/2 both sides.
Minus 1/2 x. We want to get the x away. Okay, so I'm going to do my work over here so I have room.
Dude, after this, we're done with this.
For the whole rest of the month, the rest of the semester.
I mean, we still have to do work.
Yeah. But we're close. Okay. Negative 2y is equal to negative 1/2 x plus 4. Is y quite by itself yet? Is y quite by itself yet? No, what do we have to do? Divide by negative 2. No, wait, here's the thing. Is this a fraction divided by another number? Does anyone remember,
Put one over.
okay, put a 1 under it, we like to multiply by the what instead? Remember, instead of dividing fractions, we like to multiply by the reciprocal. Very good. So instead of dividing fractions, because we have a fraction there, we'll say, well, instead of dividing it by a fraction, let's multiply by 1 over negative 2. Let's multiply by the reciprocal. That'll make our life easier. Okay. So we'll multiply by a negative 1 over 2, just to make our life easier. Because if we try dividing a fraction by a number, that's when things get messy. So we say, well, we can make that simpler. So make this over 1, make this over 1. So 1 over negative 2 times negative 2 over 1. What happens with these negative 2's? Simplify to 1, and we get what left over? Y. Now here we're going to have to multiply in, and it might be helpful for us to do this work off to the side. So I'm going to do it in the, I'm going to do this work off the side down here. My ears.
Let a choppy eat.
Might use the handle.
Sounds good.
I think it works better, yeah. It probably does right now. That one's just easy. Ooh. There you go. Seems satisfied, okay? So, I take this negative 1/2 x times negative 1/2, I bring it down here. Does anything simplify here? No, Grace's saying no, I agree with her. What's negative 1 times negative 1? Positive 1x. What's 2 times 2? Let's see what's right down. Good. 4. So we end up getting 1/4 x.
Plus.
And then we say, well, we take 4 over 1 times negative 1 over 2. Does anything simplify here?
Yes.
The 2 and the 4, what goes into both numbers?
2.
2. So how many times does 2 go into 4?
Twice.
How many times does it go into 2?
Twice.
What's 2 times negative 1?
Negative 2.
Negative 2 over 1, so just negative 2.
Yeah.
So y equals 1/4 x minus 2.
Yeah.
So what's, now if we got y by itself here, what's our m and what's our b? So we can graph. What's our m and what's our b here?
Our
B
M
is
is
negative
1 over
2.
4.
M is 1/4.
So where do we start with?
Negative 2.
Negative, we give it b. Negative 2, hey, what do we notice? We're starting in the,
Oh, dude, it's gonna be the same.
how do you know that?
Because you started at negative 2.
Because they're the same slope too and we start at the same spot. So we notice,
That's crazy.
Tony knows, hey, they're the same, guys. So how many solutions do we end up having here?
Infinitely many.
Infinitely many. Because where does it intersect here?
Yeah.
Intersect here, 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 here. Everywhere you go, they intersect.
Oh, we can just put IM.
IMS, infinitely many solutions. Okay? Now, hey guys, let's look at why this was. If we look at this equation, y equals 1/4 x minus 2. Slope and y-intercept are the same as y equals 1/4 x minus 2. Did we get literally the same equation? Everybody attention up here.
Yes.
Last part of notes and we're done.
Yes.
Did we get literally the same equation?
Yes,
we did.
Yeah, so it was the same, it's IMS. Now, if you look at the first one, did we get 100% the same equation?
No.
We had y equals negative 3 half x,
But we
y
got
equals negative 3 x.
-1 and
We got
3.
different negative 1 and 3. So when the slopes are the same, but the y-intercepts are different, but the b's are different, they'll be parallel. When the slopes are the same, but the y-intercepts are different, the b's are different, they're going to be parallel and have no solution. When both the slopes are the same, as well as the y-intercepts, they're going to be infinitely many because we're graphing the same line twice.
I have a question.
Yes.
Okay, since like on number one, like we know that we can't simplify that, right? Like the b's.
What do you mean?
Okay, so say like here, alright, real quick. So like we can go like equals 6 on one equation and then negative 1 on the other,
Uh-huh.
because they're both at the end.
Yeah.
And then we can't do that. Like we cannot
Okay, but
divide
here's the
that.
thing.
That's the thing.
So you're asking if we could know right away?
Like yeah, hold on, like negative 2 and then equals 4. That can simplify, which
But what would be 6 divided by 6?
would be 1.
So that could simplify.
I know, but like with the numbers at the end of the thing.
Yeah,
So like
6
2 divided by
simplify
4 would be.
Yeah, but 6 divided by 6 is 1.
Sure.
So you don't always, I get what you're saying, I like that you're looking for patterns, I love that. But it actually doesn't, that doesn't help us, unfortunately, because you still could get there, if that makes sense.
So at least.
So what we need to focus on though is graphing, if we get the same exact IMS. Tony said as soon as we got graphed that first point, he's like, wait, they're the same. Okay, here, never touched, no parallel, no solution.
The genius.
Okay? Hygiene is wrong.
I should definitely be like geometry or some stuff.
So,
Geometry sucks, don't take it.
I don't think that.
Wow.
Go back,
Maybe
go
I'm
back
not
to your
teacher.
No, I'm not hating on the teacher, I'm
I
hating
know.
on the class. The class, like, the material is kind of blows. Geometry sucks.
Dude, she's cheating on you, dude.
No, she's not. Dude, she has the best score in our class.
I do actually.
No, I bet not.
I bet I do.
Bet.
Look at my
We
grades.
restart the song and don't even do nothing.
Pull up.
Why would she
No.
not?
Hey, guys. Hey, here's a worksheet for us. Okay?
Go.
Here's a worksheet for us. Okay? There are 12 problems on here, 12 problems on here, okay? So what this is we're solving these systems again, okay? So we're continuing to solve systems. Now, the first one, some of these first couple, the y's are already solved for us. That's nice. They're already set up for us just to graph and then find a solution, okay? So if you guys get stuck, what can we do? Look at our
No.
notes, okay? Okay, so we're not gonna play basketball today. We're going to next time as well. We're
Oh,
going to
so we can just.
Okay. So let's just work on our own, okay? We're not going basketball today.
Can we work
We're
with
gonna
a
play it
partner?
next time, okay?
I'm gonna lay
How
on
about
the
this?
floor, bro.
If we work well for the first 7 minutes, we'll let you work with partners for the last 5.
Well, that's unfair.
We only have a little bit of time left.
That's
I
unfair.
know, but like
Okay, fine.
I'll
Let's
do
just work.
7.
Let's just work individually then the whole time.
Okay, we'll do 7 and 5.
Okay, that's fine.
It's no big deal.
Can I lay on the floor then?
Sure.
Me too.
Might take it down.
Sure. Just don't work together.